Hello, mathematicians. Today we're going to be learning about algebraic expressions, more specifically about combining like terms. To get us started, let's go over what an algebraic expression is. So, an algebraic expression is a math sentence that includes numbers, variables, and operations like addition, subtraction, multiplication, and division. Be mindful that there is no equal sign because then that would make it an equation. Before we get into like terms, let's go over what terms are. So terms are the individual parts that are separated by addition or subtraction signs. Each term can be a constant, a variable, or a combination of both with coefficients. So for example, here we have x plus 3. And in this expression, we have two terms, and those two terms are x and 3. So now let's go over what like terms are. Like terms are terms in an algebraic expression that have the same variables raised to the same exponents or are constant numbers, so numbers without variables. Only the coefficients of like terms may be different if the like terms have a variable. So here we have an example. We have 2x plus 7 plus 3x minus 3 plus y. So I'm going to color code this so we could see our like terms here. And in this case, 2x and 3x are like terms because they have the same variable and x both has the same exponent of 1. I know we can't really see the 1 there because if it has an exponent of 1, we don't have to write that exponent. But both x's are raised to the same power, so those are both like terms. And then we also have 7 and negative 3 that are also like terms. But y, on the other hand, does not have a like term. So let's go over an example. So here we have someone's order. They ordered a soda, a burger, fries, another set of fries, a burger, and another soda. So if we don't know the cost of each item, we would add up the cost of the soda plus the burger plus the fries plus the fries plus the burger plus the burger plus the burger plus the soda. So that's quite a lot. So what we could do is we could take this order and simplify it so that it's a little easier. We're going to organize it. So we're going to take the two sodas and put them together. We're going to take the burgers and put them together. And we're going to take the fries and put them together. Now, what we can do is we could take the sodas and take that cost and multiply it by 2, which is how we got 2s. So 2 sodas. And then here we have the 4 burgers plus the 2 set of fries. And this looks a lot easier than writing out 1 soda plus 1 burger plus 1 fries plus another fries plus 1 burger plus a burger plus a burger plus another soda. So here what we actually did is we put all our like terms together and we combined them. So the same thing we did with our order, we could also do with algebraic expressions. And here we're going to combine the like terms. To start us off, we have b. And if there's no visible coefficient before the variable, it's either going to be 1 or negative 1, depending on whether it's positive or negative. And in this case, b is positive, so the coefficient is 1. And now let's look at the other terms we have. So we have plus 2, which does not have a variable of b, so it cannot be a like term. Then we have plus 8b, which does have a variable that is b, and it's raised to the same power, so 8b is a like term. And then we have plus 10, which is a constant, so that's not a like term. And so we're going to go ahead and combine these two together. So we have 1b plus 8b. And the reason why we're adding is because this 8b is positive, so we're going to add them together. So 1b plus 8b is equal to 9b. And then we have a 2 here, which is a constant because it does not have a variable. And we have a 10 here, which is also a constant. And because these two are constants, we could go ahead and combine them. So we have positive 2 plus 10, and that would be 12. So plus 12. So b plus 2 plus 8b plus 10 is equivalent to 9b plus 12. Here we have another example, which is 5x plus 3y minus 2x plus 7y plus 14. So let's go ahead and combine like terms. To get us started, let's use 5x and see if we have any like terms with 5x. So the next term is plus 3y, and that variable is different, so those are not like terms. Then we have minus 2x, so we have an x raised to the same power, which is 1. And then we have plus 7y, which is not a like term, and then we have plus 14, which is not a like term. So let's go ahead and combine 5x and negative 2x. So this would be 5x minus 2x, which would give us 3x. Now let's move on to 3y. So this is a positive 3y, and so we're going to look for other terms that also have y as a variable. And in this case, we have plus 7y. So 3y plus 7y is equal to 10y, and that is positive, so we're going to put plus 10y. And then here we have 14, which is a constant, and it's by itself, so we're going to just go ahead and bring it down. So 5x plus 3y minus 2x plus 7y plus 14 is equal to 3x plus 10y plus 14. Here we have another algebraic expression, which is 2x squared plus 5x plus 6 plus 7x minus x squared minus 4. So let's start off with 2x squared and find its like terms. Now the next term is 5x, but notice that even though we have the same variable, they're not raised to the same exponent, so they're not like terms. The only other like term to 2x squared is negative x squared. And remember, if there's no visible coefficient before the variable, then the coefficient is either 1 or negative 1, depending on whether it's positive or negative. And in this case, it's negative, so our coefficient is negative 1. So 2x squared minus 1x squared is equal to 1x squared, or we could just say x squared. Then we have 5x, and our like term to 5x is 7x. So 5x plus 7x, because they're both positive, is equal to 12x. And then we have 6, which is a constant, and we have negative 4, which is another constant. And 6 minus 4 is equal to positive 2, so that's why we put plus 2. So 2x squared plus 5x plus 6 plus 7x minus x squared minus 4 is equivalent to x squared plus 12x plus 2. Here we have our final example, which is 10ab plus 6a minus 7b plus 12ab. Now here we have 10ab, so our like term has to have both the variable a and b. So 6a and negative 7b would not be like terms because 6a just has a as a variable, and negative 7b just has b as a variable. So the only other like term is 12ab. So 10ab plus 12ab is equal to 22ab. And then 6a does not have a like term, so we bring it down. And negative 7b does not have a like term, so we bring it down. So 10ab plus 6a minus 7b plus 12ab is equal to 22ab plus 6ab minus 7b.